Cool. So hello everyone. Welcome to another Backend lecture series. And today I know that we should have talked about cloud, but there's some change of plans, so we decided to talk about database first. And this would kind of be like a introduction to database development. We will first cover different types of databases, specifically like SQL versus NoSQL database. And then we are going to have build a to-do app that kind of serves as an example for you to use Python API to communicate with a SQL database that's built on your local computer. So yeah, everything. So that's pretty exciting. And now let's get into it. So essentially, so the first question is what is a database? If you haven't took 96, essentially database is kind of like an infrastructure to store a large amount of data. And actually so you can kind of think of your file system as a database. Those actually something different, but it serves a very similar purpose. It's storing files. Essentially database is pretty similar to that. The only difference is that instead of storing large files, it's storing data. And database is all around us. Facebook use data, Instagram use data, essentially everything use data. And when you share a photo on your Instagram, the photo will be stored into a database. And essentially, yeah. And there are mainly two sorts of databases. One is called SQL database and one is called NoSQL database. And so essentially, okay, so what are those? So first of all, SQL database. SQL database is what you will actually be learning in YD6 if you took the course. And essentially, it's kind of like the traditional way of storing all the data. As you can see, here in this image, this is kind of like a very conventional representation of a SQL database. Essentially, the database is very, very similar to our table. And it has a column name, and it has different rows under each column. So let's look at the example here. The example here is a database consisting of name, age, and country. And there usually will be a row number here, row index here, but it's kind of the default. So probably they're not showing this here. But so for each column, there will be data underneath the column. Essentially, if we look at the first row, it consists of name and the age of 11, the country of Iceland. So essentially, this first row is kind of one data entry. So essentially, SQL database kind of treat data as entries, and each entries is usually each row. So essentially, here is a row. Here's a row, and here's would be one entry, and here will be another entry. Here will be another entry, and there are in total 4 entries in this databases. And there are a lot of common and SQL database is very, very common. It's super robust, and it's the database that that's the oldest database format. That's essentially there are different variations of SQL database as well. For example, there's MySQL, there's Sqlite, and there's Oracle Cloud Database. These are all variations of SQL database. And for this course, we are going to cover Sqlite. And Sqlite is essentially a very easy to use, kind of a Python built-in database. And Sqlite database is actually kind of built based on top of file system, which means that you don't really need to have a server to load the database. So essentially, usually database is you need a separate server to load the database. However, for Sqlite, you don't actually need to set up the server. You just need to create a file called database.db, and then the file will serve as the purpose of the database, and you can interact with the file through a various Sqlite commands in Python. So yeah, Sqlite is what we are going to cover. So this is SQL database. When you are imagining SQL database, just imagine a table. It's pretty straightforward. And so what's NoSQL database? NoSQL database is essentially databases that do not use SQL to define or manipulate data. In other words, NoSQL databases are those databases that do not store data in a traditional table format. And there's a very, very popular database called MongoDB. MongoDB is essentially I would say one of the most popular NoSQL database. And instead of like using a table-like structure, they use a document-like structure, or you can also as like tree-like structure, JSON-like structure to store all your data. As you can see, like in this picture, it's kind of like instead of like table here, it's like there's an entry, there's a property called field, a first name, and then it's Paul, and then surname is Miller. Essentially, this whole thing, the whole thing in this bracket is one database entry. And if there's like another database entry, it will be gonna be like another person's information. So say like first name, it will be Alex, surname will be Wu, cell phone will be like my cell phone. So essentially like this is how MongoDB structured their data. Instead of like storing it in row, you store it as a JSON object. You can like think of it this way. You store it as JSON object. And when you're like retrieving it, usually like you can look up specific like attributes within the object. So say if you want to like look up people with the first name Paul, and then you will like essentially just return this object as a result. So essentially, yeah, that's kind of like the JSON data. And as you can see, that's kind of like the NoSQL database. As you can see, data can also be nested. It works like very, very similar to a NoSQL database. To a JSON format data. And here you can see like there's a cars attribute, and in the cars attribute there are like also various kinds of data. And that's a pretty like common scheme in NoSQL database. Essentially, like data can be nested within each one, within one another. So yeah, so this is NoSQL database. We'll be covering NoSQL database and how do you connect, for example, Node.js to MongoDB in the lecture, in the future lecture. So yeah. And usually, okay, so now let's get into like how, actually before that, are there any questions? Cool, okay. Yeah, so those are just like introduction to database. It should be pretty conceptual. And now let's talk about like how do databases usually work with the backend server. So essentially, in the week before, we have covered Flask, and we have also covered Express. Flask and Express, or like Flask and Node, these two are kind of like the very popular backend framework, the server framework. And when you have the server in place, usually if you want to like store some data into your local server, you usually use a database. And that's where the database comes in place. And so essentially like for this particular track, backend track, we have picked two different combinations of backend server and database. So today we're going to talk about Flask plus Sqlite. And it's kind of like the go-to Python choice. If you want to like decide to do a server in Python, essentially you use Flask and you use Sql Alchemy, kind of like an application interface to connect Flask with a Sqlite database. And we will be like covering this in much detail later. And we also will cover Express plus MongoDB, just like we've said. Essentially, it's like if you decide to build your server in JavaScript, then you can just use Express plus MongoDB. And some people may actually like prefer NoSQL database to SQL database, because like NoSQL database is kind of like more intuitive, and yeah, so you may find like using MongoDB a little bit more easier, a little bit easier. So yeah, so this is kind of like our future plan. And now let's talk about Flask plus SQLite. So essentially SQLite, just like we've talked about, it's a very, very lightweight SQL database that's super easy to set up. And essentially, I can show you kind of like what you would expect after you set this up. Let's see. Yeah, so essentially like this is the to-do app that we are going to build in a second. These are like all the endpoints. As you can see here, there's a to-do.db file. You can't really view it in VS Code because like this is a customized database file. However, this file will serve the entire purpose of what kind of like serve the entire SQLite database. And with the help of this one file, we can like create a database. Essentially, so this is, as you can imagine, like pretty easy to maintain. If you want to say delete the database and create a new one, you can just like delete the file and create a new one, your command line. So yeah, it's like, so for example, in PostgreSQL, it's another like variation of SQL database. You need to like type in some pretty weird command to like delete something or like clean up a database. And with SQLite, it's like everything's super easy. So yeah, so that's kind of like why we choose SQLite. And to connect Flask with SQLite, we're going to use a Python toolkit called Sql Alchemy. And Sql Alchemy is kind of like the go-to toolkit if you want to like use Python with SQL. Sql Alchemy does not only like connect the Flask with SQLite, it also can connect Flask to PostgreSQL. It can also connect Flask to like a bunch of other SQL databases. So essentially, like if you decided that SQLite is like too small or the performance is like not that good for you, you decided to switch to some like more robust production level database, you can then switch it super easily. Essentially, it's just like change this one line of code and then you are okay to go. So yeah, SQL Alchemy is a very, very powerful application interface that's built for Python and also SQL databases. And the objective of our course today is to build a to-do app. If you can remember, essentially like the week before, we've built a dummy to-do app in Flask. Essentially, it's like you can only like when you add something, you are not really add something. It's just like feeding the to-do ID back to you and feeding the to-do content back to you. It's not really like storing anything on the local computer. So that's kind of like dumb. And today we're going to like upgrade the whole to-do app and make it like a real to-do app, a to-do app that when the user decides to like add things into it, it will actually add things into it. Like it will actually get stored in the database. And if we think about like the design of the to-do app, there are essentially like three main parts. Maybe like 4 main parts. What to do. Yeah. And the first part is to create a to-do. So the user needs to, first of all, send the to-do data, like a to-do title, and then the to-do content or the description in the server, and then the server will store the relevant information into a database. So this is kind of like the first function. The second function is to view a to-do. Essentially is to, if the users like inquiry about one to-do or like all the to-dos, the server can then go and fetch all to-dos or a single to-do from the database. So this is kind of like the view function. And the third functionality that we need is a way for user to update their already created to-do. So say if like they want to buy milk in the morning and they decide not to buy it like during the afternoon, and they can just like change it to like, I don't know, buy spaghetti, for example, and then like, or by pasta, for example. And so that's kind of like the serve functionality. And there's also a very important functionality, which is like delete and to do. The user should be able to delete something in the database. So yeah, so that's kind of like the 4 functionality that we are aiming for. Now let's see. So right now we have this preparation. It's kind of like a skeleton code. And you can find it here. Essentially, just copy and paste it into your like VS Code or whatever. And you can name it, for example, called todo.py. Well, we can do this. Okay. Actually, you know what? Let's. Okay. Yeah, I've already like copied it here. So essentially, here I have kind of like a before class material folder, and inside it there's only like one todo.py, and as you can see, there are like a few tasks that I have outlined. But before we go into a task, let's actually take a look at the data at the file together. So as you can see, this is a Flask file, and it's creating like a Flask server. So this should all be pretty like familiar. And here in the first row, it's essentially it's saying welcome to the to-do app. It's like welcoming us to the to-do app. And here in the route of like to-do and list, it will call the method of get all to-dos. So essentially like this will return all the to-dos. And here the result is just like a dummy thing because like we have not really built out the database yet. And here get single to-do. Here the route is essentially like to-do and then followed by to-do ID. And to-do ID is essentially like if the user only wants to view one particular to-do, then the database should be able to like find it and fetch it for the user. And so this is what this endpoint is for. There's also create to-do. And how do we create to-do? Essentially like we create it by directly passing the to-do content in the URL. Why do we do this? Because usually the to-do content is being passed in the body of the request. However, like for the like sake of this course, which is like to develop the to-do app easily, or like more easily, we decided to just like put the to-do content in the URL. But that's something that people usually don't do. So essentially, like usually, if you want to build like a pretty robust to-do app, you probably need to put the to-do content in the request body. So something we've covered about in the REST API course. So yeah, but right now we don't really care about that. We just want to learn about database. So and yeah, so that's for create to-do. Essentially, you are passing on to-do content, and we should automatically find a to-do ID for it. And also we will return a to-do content. There's also a delete to-do method here. Essentially, it's like when the user go to do, delete, followed by to-do ID, it will essentially delete that particular to-do with that particular to-do ID. There's also an update route. Essentially, like the user can update one of the to-do ID by offering a to-do ID parameter and also a to-do content parameter. Essentially, well, the database will fetch the to-do ID and then go and update the to-do content within the to-do ID. So that's essentially like a brief introduction of our dummy to-do app. Now let's spin it up. So let's do Flask run. Oh yeah, I haven't provided that. Let's just do Python to-do app. Or you can use the environmental variable that we've talked about like last class, but I think it's fine. Wait. Oops. Oh, yeah, I'm in the wrong folder. So let's go to here, Flask run. Yeah, Flask probably cannot automatically detect it. So we can also run like Python to-do.py. It's essentially the same thing. And let's go to this URL. And as you can see, it's saying like, welcome to the to-do app. And if we change it to another, for example, to-do list, and it will say like purchase have phrase Java. And it's essentially the dummy thing that we return here. Yeah, so essentially this is our server right now. Actually, any questions for the setup?
Wait, sorry. I do
Yeah.
have a question.
Mhm.
What is the Flask app that you talked about? That error that came up?
The Flask, you mean the Flask server?
Or the like in the terminal when you tried to run it?
Oh, yeah, sure. So essentially, how do I run it? It's just by doing Python to do.py. Just like, yeah, you can also do it the other way. Let me just like put it in chat. Yeah, so essentially it's just how you would run a normal Python file. And you can also do it like the other way, the proper way, which is, I believe we've covered this during our Flask lecture. We can like check how should we properly run this. Yeah, so essentially we should be running this. So it's saying like we give Flask app kind of like an entry point and then do Flask run. Yeah, we can try this as well. So let's stop it and change hello.py to essentially to-do.py. Yeah, as it's essentially the same thing. The
Oh,
Flask
okay.
run will run that to-do.py. Yeah.
Okay, thank you.
Yeah, no worries. So this is kind of like the proper way to do it. Let me send in chat as well. Change hello.py to to-do.py. Server. Okay. To the file name, to the name of the file of the server. Okay. Cool. Any other questions? Oops, I accidentally closed the Notion. Cool. So if there's no question, let's like get started with creating the actual database. So the first question is like, how do we actually create a Sqlite database? So essentially, the way to create Sqlite database is like super easy. And first of all, you need to like add this line to the kind of like the app, which tells where the Sqlite database is going to be. And essentially, like since the database is going to be pretty simple, we'll just like put it in the root folder. And how to make it, how to make the program know that's in the root folder. Essentially, like this will be the root folder, and this name will be essentially like the file that's inside the root folder. Essentially, this URL here is saying that you will go to the same folder with the server file and then look up the todo.db file. And so let's paste this in. This is kind of like a config. You have to configure it like this if you want to like have the todo.db file in the folder. And also, just like what we have mentioned, we are going to use a pretty powerful application interface that's called Sql Alchemy. So let's go ahead and store it or import it. And also, you probably need to download this. So let's see. So for Sql Alchemy, you can go to here, and then like how to install, you probably just install it using pip. We can double check. Yeah, essentially like you just run this command, we can run here. And so let's start the server. run it. Cool, and you should have it stored. And I'll send the comment in chat as well. SQL Alchemy is a very powerful way for you to like connect to the databases. And once we have that installed, we can like import it this way. And how do we actually use it? We use it by calling db equals SQL Alchemy app. Essentially, this is kind of like, it works kind of like a decorator. Essentially, like you first create a Flask server app, and then you call SQL Alchemy as kind of like the higher order function on the app. And then after you call it, it will create a database, kind of like database variable. And this database variable or database object will be kind of like our point of interaction. So essentially, like every time we want to like send something down to the database, we'll call this database, we'll call the methods on this DB variable. And so yeah, so that's for the setup. And afterwards, this is kind of like just like importing everything. However, to make a SQL database, we actually need to create a database model. So essentially, what is a database model? For SQL databases, you can think of database model kind of like the columns of the table. So essentially, for this particular database, there are like 3 columns, right? There's name, age, and country. Now for our to-do app, if you really think about it, we actually only need kind of like, like 2 columns. The first column would be kind of like our ID. So essentially like the ID of the to-do is kind of like the unique identifier of the to-do. And second of all, we need a content. Essentially like it's the thing that's inside the to-do. So essentially like buying milk will be the content. And if it's the first to-do, it will have like an ID of 0, and 0 will be the ID. Yeah, so this is kind of like the intuitive understanding of our database model. And how do we actually build this model out? And let's look at the code. So let's first of all copy and paste it here. And essentially, how you create this is you create a class variable inside the class to do. Essentially, the class to do here, first of all, it extends db.model. So db.model is a class provided by the SQL Alchemy package. And by extend db.model, essentially the SQL Alchemy package wasn't like be able to know that to do will be a model for our database. And how do we actually create a row or like how do we actually create a column, the field name for the database? Is by using by creating class variable inside the class. So since we're only going to have 2 columns, we just need 2 variables. So the first variable would be ID. It's kind of like the default in a SQL database. You have to have that, and you follow by calling the db.column. It's essentially saying that, okay, so ID will be a column within the database. And then followed by the database, followed by the data type of ID. Since ID is kind of like the unique identifier, we want that to be like simply an integer. Integer will like, and also like if you call the database column ID, you'll automatically increment itself. So this is kind of like anything that is already being handled by SQL database. And you don't really need to like increment it by hand. So that's pretty neat. And so yeah, so db.integer is kind of like the type that we want the ID to have. Also primary key equals true. So what is primary key? Primary key is essentially, it's essentially saying that the ID will be the unique identifier. So 0 will be like no 2 zeros or no 2 ones. 0 will be like no 0, 0, 1, 2, 3, 4, 5. It can only be like 0, 1, 2, 3, 4, 5, 6, 7, 8. It can only be like incremented. There can't be like 2 ID variables that share the same name. So that's kind of like primary key equals true. So that's for our like ID column. There's also the content column. Essentially, like keep storing all the to-do contents. And the content column, first of all, we call it db.column, which makes it a database column. And then we call it db.string and followed by 200. What does that mean? That it's kind of like saying that, so first of all, the content should be a string and it should be limited within 200 characters. You can think of it kind of like as a tweet. So you know how like tweet needs to like limit your character in like 140 words, and db.string is kind of like very similar to that. You need to like limit it to like 200 characters, and nullable equals false. So what does that mean? That means that the content must have something. So if we look at our database here, if we look at the example database here, essentially like here, all the entry or all the cell is filled. However, sometimes the cell can be empty as well. So for example, if Laura here doesn't know her age, then we'll have like an empty cell here. And if the age column doesn't have like nullable equals false, this can be like completely fine. However, with nullable equals false, it means that the column cannot have any null values. As a result, if the age also has like nullable equals false, then it means that everything inside this column, it needs to have some like something filled in. So if there's like a null value here, it will have an error. So that's kind of like the nullable equals false. And why do we have nullable equals false here? Because like we don't really want to have an empty to do. That's kind of dumb. So yeah. And so that's for the two database column. Are there any questions so far?
I guess I have a question.
Yeah.
Sorry. What does one instance of a to-do represent? Does it represent like a table?
Yeah, so essentially like if we so we can look at this. We can look at this. Okay, so essentially like let me do it this way. So it kind of so this is kind of tricky. So essentially to do here, it sort of represent both the table and the like one to do row. Essentially like if you look at the final result of our code, here there's a to-do.query.all. This is essentially saying that we will look up all the entries in the database and we are calling the to-do here. However, so that's kind of, I know this is maybe a little bit strange, but this is like how Sql Alchemy works. You can also call like to-do content, and this will actually provide you with one row like in the table database. So it can both be like a database, like an access point to the database, and also kind of like a way to create a new to-do.
Okay, got it.
Yeah. I think you'll be clearer once we like get to build the actual database out. So yeah, but that's a good question. I know SQL can be a little bit like confusing from time to time. Any other questions? Cool. Okay. Let's see. So essentially, like we also need to provide two methods for the class to do, and this is kind of like where things get tricky. So essentially, first of all, we need to provide an init method. And notice that the init method is actually not like kind of like where you would initialize the database. Instead, it's init method is used to like initialize a new to do. So essentially, if you want to build a new to do, and then you simply can call like new to do, or probably like to do, and then you just provide the content. So like buy milk, and then you're just done. Because like, yeah. And why do we don't like include ID? Because like SQL will actually handle ID automatically for you. Essentially, like it will initialize it at 0 and then increment as you like go up. You don't really need to create a field for that. Like in the init function, it will automatically handle that for you. So that's pretty neat. So that's for the init function. It's essentially like it's taking a content parameter and then set the content to self.content. This is essentially saying like the content of the to-do will be the content parameter. There's some question in the chat. Because of primary key, yes, essentially, yeah, this is essentially because of primary key. And also probably because of the ID keyword. I believe that the ID is kind of like a reserved keyword in SQL databases. So yeah, but yeah, primary key is also like one like big factor. Yeah, why do I think like ID is a reserved keyword? Because like you can actually see it's like highlighted in a different way, in a different color. So yeah. And there's also this wrapper function. Why do we need wrapper function? So for people who don't know, the wrapper function is essentially like a way to represent a object when you are like printing this out. So say if you want to like print. So first of all, so let's say we have like to do call by milk. Let's just call it M, stands for milk. And if we want to print out milk, if we do this without the wrapper function, it will print out say like database object, like something weird. However, if you like use this wrapper method, it's essentially instead of like printing the actual object out, it will print this formatted string out. So this is essentially a way to make things like prettier and easier to understand. So that's for wrapper method. As you can see, wrapper method, it's just a Python string formatting. It's it will output a string that contains to-do ID and its ID, and also to-do content and also its content. Essentially, like those two variables will fill in the curly bracket here. So yeah, so that's for the wrapper function. Are there any questions so far? Cool. So let's create the actual database. Because like we previously, like just now, we were just like creating a model, and we have not like actually created the database in our folder. As you can see, like in our folder, there's no like to-do.db file, and we actually want that to like initialize our database. So how do we actually do it? It's surprisingly super simple. Essentially, you open up another console, and then so first of all, make sure you're in the right place, and then you call Python 3 or Python whatever you want, and then you from to do import db. And what does this do? Essentially, since we're running the cell, running the terminal inside the before class material folder, and if you do the from to do import db, it's essentially saying that we will import the db variable from this like to-do.py file. And this is essentially how we get the db variable outside of the like this file. And once we get that in place, you should be able to see like a bunch of like warning message. You can ignore it. But yeah, if you don't see like any warning message, it may be that case, but it also means you are fine. If you see any error, then it means there's maybe something wrong with like your code. And after you import it, you call db.create all. And you won't see anything, but essentially like this will actually like create a database for you. And how do we check? We can see essentially like the todo.db file created in the before class material folder. And if you see it, then congrats, you successfully created your like first Sqlite databases. As you can tell, this is like super easy. It's very straightforward to create. Like usually with like other databases, for example, PostgreSQL, I'm actually running one right now here. It's essentially like super hard to use. You need to have a graphic interface, it's just super hard to use. Sqlite is, yeah, it's straightforward. It's pretty nice. Wait, what? Okay, cool. And now, since we have our database in place, that's actually before this, are there any questions? There's some question in chat. Okay, yeah, I've never used MariaDB, but yeah, okay. Is that a SQL database or no SQL database? I'm guessing that it's a SQL database because I feel like SQL database. Oh yeah, I feel like. Oh. Okay, yeah, I feel like all SQL database is like super annoying to use. So cool. Yeah, let's see. Okay. Okay, so now let's get to work on the some like CURD operations to the database. What's kind of like CURD operation? It's essentially a way. It stands for like create, update, retrieve, and delete. This is kind of like the 4 main operations that you will ever perform in like on your database. Essentially, like the ability to create something, to update something, to retrieve something, to delete something. And this is kind of like the essence of databases. Yeah. And so let's try to do this. And we have created like several endpoints that we should have used. This is just like for yes, this is just like a general guidance. You don't need to like use this specific endpoint. We just put it here so that you can like keep track of all the endpoints that we're building. And now let's create the create to do endpoint. So, and to create a to do, essentially we'll use the db.session.add. And so how to like when you are dealing with a database, it's actually pretty tricky. It's not like you just add it and then it's going to database. It's not like that. You have to, first of all, when you are using a database, you usually create a kind of like a session, and you can add things to a session, and then after you call commit, and then all the changes will be flushed down into the database. It's kind of similar to Git, how you need to like .add and then .commit. Actually, as I believe Git gets their like inspiration from like databases. So yeah, and this is kind of like a way for you to like ensure all the changes that you want will be like flushed to the databases. And so yeah, so how do we actually create a to-do? It's very simple. So first of all, we get the to-do content from the endpoint, and then we first of all create a new to-do or kind of like a temp to-do. And this temp, how do we create a temp to-do? We just call the to-do constructor. And then since we have the init method here, and it only takes in like one parameter, which is the content, it will just like automatically create a new to-do. And then, yeah, this is like just creating a new to-do. And this to-do will have the content and will automatically have the ID. And once you have the new to-do, you call db.session.add. So it will create a session, a database session, and it will add the variable into the session. And you can add like multiple variables into one session or like multiple operations into one session and then commit it all together. That's kind of like one way to do it. And here, because like we are only doing one operation here, so we just add it and then we call commit. And after we call commit, essentially the to-do will then be like added to the database. And after we call commit, we can then return this like first of all, we can return a new to-do ID, and then followed by its content. And this way that the user can like double check whether the new to-do has been successfully created. Cool, so let's do that. Let's copy and paste it here. First we find our create to-do. So yeah, it's here. Copy it and we delete the previous one. And we click save. Probably need to run the server again. So let's run it. Let's first go to the root URL. Yeah, okay. There's no error, and let's just check which URL should we go to. We should go to /to-do/create followed by the to-do content. So let's go to this. Okay, so what do we want to do? I don't know. Review one. Let's see. What are some things that I actually want to do? Start CS194 project. 5, is it 5? Yeah. And after we call it, as you can see, the browser will automatically like parse the space into this. This is kind of like the ASCII for spaces. Not really the ASCII, but it's probably the Unicode. I need to double check on that. But yeah, the Unicode for spaces. And then we will get this as return, which is 1, and start CS194 project 5. Essentially, yeah, essentially we get what we want. If we look at the endpoint, we get a new to-do.id and to-do content. Notice that we have never added a ID like explicitly. The ID is something that's created like on the fly by the database itself. So yeah, so that's pretty neat. Yeah. And let's actually create another one and see if the ID will be like automatically incremented. So I don't know, just buy milk. Yeah, and as you can see, like here for the second to do, it automatically increments to like 2, which is pretty good. And then let's do buy orange juice, because why not? Okay, yeah, as you probably get the idea. It will automatically increment the to the ID. So yeah, that's that. Maybe one question is like why the 3 is like instead of like an integer, it's a string, because like we have JSONify everything, which means this is kind of like a package in Python where yeah, essentially automatically make everything JSON data, and JSON data is like our go-to type when it comes to like data transmission. So yeah. So cool. Any questions for the to-do endpoint? Okay, then let's move on to the next endpoint. So right now we have to do, but we kind of like, we're not retrieving it properly, because like we can only see the to-do content, like the to-do ID and the to-do content, like after we call the create endpoint. That's something we don't really want. We want to like have a dedicated endpoint that's like dedicated to do like retrieving to-dos, so that we can like give the user what they want, instead of like creating a to-do every time we want to have a new to-do. And so this is where we will build the to-do list endpoint. And this endpoint will be in charge of like retrieving all the objects. So let's do that. So first of all, let's find the list here, and then copy and paste it. And essentially here, the user will, so how do we actually retrieve all the to-dos? We do this by calling, first of all, we do this by calling the query on the to-do class. This may be a little bit confusing because like the to-do class right now is kind of like serving both as a database access point and also a method, a constructing method for creating a new to-do. But this is essentially like how we work with Sqlite or like Sql Alchemy. And by calling todo.query.all, it will return everything that's being stored in the database. And it will return as a list of objects. And since list of objects, it's like pretty hard to like use. We convert it into a list of todo.id and todo.content tuple. And this way we can like JSONify it like in an easier way. Otherwise, it's pretty hard to like JSONify an object. So let's rerun it. Save it, rerun it. And then, oops, I've created an extra orange juice to do. But let's go to this app as this URL. Okay, let's visit. And we see that we have like a list of lists. It consists of like the to-do ID and also the to-do content, which is pretty neat. And essentially like this is what we return. We've returned like a big list consisting of like small lists. It's actually tuple, but because like the JSONify process will converting tuple into like arrays. As a result, we can only see like arrays here, but it's fine. Now we have kind of like a way to visualize all the to-dos that we have created. So this is pretty neat. We should like save it into another tab so we can like work on some other. So let's say we want to like, instead of buying milk, we want to add a new to-do. Let's say like, I don't know, like buy iPhone 12. I'm running out of new to-dos. And as you can see, it will create here. And if we refresh our to-do list endpoint, then we can see that it's listed here down below. Any questions for the list endpoint? Cool. Actually, before I forget, let me just take the attendance real quick again, because like some people join a little bit late. Sorry about that. Let me do that. Oops. Okay. Cool. So yeah. Now we have the retrieve endpoint in place. Now, but this particular endpoint is just like retrieving all the to-dos. However, what if we only want like one to-do? This is where this endpoint is useful. So here is the get single to-do endpoint. And get single to-do endpoint takes in a to-do ID, and then you query on like specific one specific to-do. And we do the query by calling to-do.query.filter by. And the filter by method will essentially like takes in a way to filter the to-do. You can do that by ID, or you can do that by like the actual content. If you want to do the content, you just do like content equals like content. But here we are just going to use ID because like that's like more intuitive. You will also call the dot first method. And why do you call the dot first method? Because like this will actually return like this will actually returns kind of like a list of objects. And when you call it like dot first, it kind of like fetch the first element that's like being matched. Because like right now here, we only will expect the database to return one item, since like ID is the unique identifier. So we essentially just call dot first instead of like dot all and then checking the size and blah blah blah. So after we get the single to do, we just return it. And this should be pretty intuitive. Now let's save it and rerun it. And let's go to the endpoint. So what's the endpoint? It's to do and followed by ID. Let's see the first. Okay, so if we like do to do 1, and then we get the first. If we get 5, we get the 5th. So that's like working as expected. So that's all for the retrieval endpoint. And after we get the retrieval endpoint, let's get the delete endpoint. The delete endpoint is essentially like a way for the user to delete specific to do when the user don't want like some to do. So let's do that. And how do we delete something? Essentially, we do it by so as you can tell, there's one like big difference from like delete to do and like get to do. So essentially, every time when we want to do an update on the database, then we need to like create a session and call like a session.commit. If we're just like retrieving things from the database instead of like updating it or writing into it or like deleting it, we don't really need to call the db.session. We just need to like use the .query and then it will like automatically do the query for us. Yeah. So only when we call commit, only when we are like actually updating something in the database. So that's kind of like important to remember. And so how do we actually delete a database? To delete an entry in the database, we need to first of all find the particular entry. And then we pass this entry into the delete method. So how do we do this? First of all, we call the .filter by ID. It's essentially the same thing here. As you can see, it's like exactly the same. And we then call db.session.delete. Oops. And it takes in a single to do, it essentially takes in a to do entry, and then it will delete the to do, and then we call commit, and then it will be like essentially be deleted. So let's see. Stop the server, run it again. Run it again. Let's see. Our entry point is to do delete. So let's say we want to delete our first to do. Let's go delete. And it will say like 1 and delete it. If we refresh, we can see like the first is gone. Let's delete 3. Oops. 3. The 3 is deleted. So you can see it's deleted. We can try to create a new one. Let's say like by orange milk, by chocolate. Did I spell chocolate correctly? Yeah, I spelled chocolate correctly. Okay, cool. Yeah, so essentially like this one, if we call it again, as you can see, like it will not, instead of like filling in the gap, instead of like filling to do like as 1, it will actually create a new, it will actually increment the ID. So this is something that's pretty interesting. So yeah, it doesn't really matter that much because like the database handle it all for you, but it's pretty interesting to know that it's actually like doing the increments. So like filling the gap. Yeah. Cool. That's for the delete endpoint. Are there any questions so far? Cool. So now we've got to our final endpoint, and this is the update to do. And update to do is essentially very, very similar to delete to do, as you can imagine. And update to do essentially it takes in first of all a to do ID and then a to do content. And as you can tell, it's very similar to the delete to do. And first of all, we still need to find that single to do. And after we find it, we just change the content this way. It's like, I know it's like super simple and straightforward, but this is how the Sql Alchemy package handles it for you. It's like super straightforward. You just change it by doing this. And then you call db.session.commit, and then everything will be committed. And the changes will be made, and we will return like the updated to do ID and also content. So let's do it. We run the Flask app again. Okay, so instead of let's see. So we should go to do update. And then let's update the, let's say we want to update the 5th one, because I don't really want to buy it to iPhone 12. So it should be to do ID and followed by the actual thing that I want. So I don't know. Let's do homework. As you can tell, like after we run this, it returns 5 and do homework. And if we refresh the get retrieve all endpoints, we can see that the changes is being reflected here. And so essentially, yeah, that's it for all our endpoints. And this is like a very, very simple to-do app. As you can imagine, it can actually, by using like the simple database interface APIs, you can create like some very, very sophisticated stuff. For instance, if you want to store, like if you want to build a user database, you can just like create endpoint that's in charge of like storing the username and a database into the database. You probably need an actual like hash function to hash the database to hash the user password before storing to a database. But that's essentially it. So essentially, we have covered like the most important operations for a database. So that's it. Any questions? I would, I will stop recording.